using that part. We're just going to start from here. Unit 6. Okay, similar triangles. The idea of similar triangles is literally what the name says. You've got two triangles that are similar. And the reason they're going to be similar is they'll have the same angles. They'll have the same angle. So if that's 70, 30, that's 100. That means this one's 80. Well, this one's also 80. But they're not equal triangles. And as you can see, they have the same angles, but the triangles are different in size, right? One triangle's smaller, the other triangle's larger. So in this case, we say these triangles are similar. They're not equal. Now, when we have similar triangles, usually we've got to find the matching angles and eventually the matching sides. Pretty straightforward. Remember I said that? So angle A is equal to, come on, someone finish this off. Angle A equals angle B equals angle.
Angle A equals angle D.
Angle B equals angle
B equals angle A.
Yep, and then angle C equals angle. Remember, when I say easy, I really mean it. When I say hard, I really mean it. You guys know that. So these ones are not a problem. Write the matching sides. AB equals. What's the matching side to AB?
DE.
DE. But look, let's just get something clear. The length of this does not equal to the length of this. It's just saying write the matching side. So don't think AB is the same size as DE. It's just in the same, it matches. Let's get that clear. But for the top one, they're actually equal to each other. Right? Yep. Annabelle, were you going to say something?
I just said it's on the sides. It's more the ratio.
Yeah, good. AC is the same ratio as DF. All right. And then complete triangle ABC is similar to, so the way we write similar is 3 vertical lines. 1, 2, 3. Triangle ABC is similar to triangle DEF. Any questions there? Yusuf, all good with that? Trinity, any questions there? Oh, all good. Okay, let's see. In the following pair of triangles, write the ratio of matching sides. LM to PQ. What's LM to PQ? Or what's LM? 6 over. What's PQ? 12. What is that equal to? A half. MN to QR. 4 to 8. Which equals a half. And then NL to RP is 5 to 10, which is also a half. Because they're all in the same ratio, that means triangle LNM is also similar to triangle PRQ. Any questions there? Matt, Andrea, any questions?
Sam, have you given us this booklet yet?
I think I just sent, didn't I just send it maybe? Oh no. Book 5, yeah, I've just sent it across. It's unit 6.
Okay, thank you.
All right, let's scroll down. I think these are easy. All right, so let's have a look at these. To determine whether or not the pair of triangles is necessarily similar. If they are similar, write the similarity statement and state the test. All right. So let's make sure we can match them firstly. What angle matches with angle A?
Angle A.
So angle A equals angle E. Let's write it better. Hold on. I don't really like writing like that. Angle BAC equals angle, DEF. They're both 60 degrees. Yep. So these two are the same. What else? What else can you guys see?
Angle C or angle ACB would be 180 minus 70 minus 60, which would be 50.
That is actually 50 degrees. If
Therefore,
that's 50, yep. Therefore,
FDE.
yep. So angle ACB must equal to angle FDE. FDE, because they're both 50 degrees. And in fact, you only ever need to solve two angles for it to be the same. Because if two angles are the same in a triangle, what must happen to the third angle automatically?
It's also the same.
Yeah, so we technically don't ever need to find a third one. Because if two angles are the same in a triangle, then the third one will automatically be equal. So you don't need to actually write the third one. Therefore, triangle ABC is similar to triangle DEF. And the reason is we call it, there's a fancy way of calling it equiangular. Right now, I'm just going to write angle, angle, angle. So all three angles are the same. A. Angle, angle, angle. So all angles are going to be equal. Since all angles are equal, they must be similar. Does that make sense?
Yeah.
Yeah. Well, you can see for this one, unfortunately, I don't have all the angles. So I can't say, I don't know what value this is. I can't say that angle is equal to that angle or this angle. I can say that's 90 and that's 90. That's good, but then I'm stuck. So I can't exactly use this angle, angle, angle reason. There's going to be a different approach to this. And that approach is going to come through the ratios. So what we're going to hope is that ST on what? So this on, what's the side that would be equivalent to ST or matching to ST?
16.8, so QP.
So QP. We're hoping that ST on QP is the same as RT on RP. So let's see. This is 14 on 16.8, which simplifies to 5 on 6. And I don't have much more room. 98.5 on 118.2. If you plug it into our calculator, should also give you 5/6. Since, whoops. Sorry. Therefore, wait, one more. Angle RQP, angle RQP also equals RST. Therefore, triangle RQP is similar to triangle RST. And the reason in this case is side, angle, side. So side, angle, side. There's a side that matches, a side that matches, and an angle that matches. Side, angle, side. So there's AAA, and then there's SAS. Side, where are we? Side, angle, side. Technically an RHS, but I'm not going to get into that. Let's just leave it as an SAS for now. And we do it again. Who wants to start this one off? Pretty much exactly the same as B. You're hoping that two of the sides are in the same ratio, and then what? Two sides are in the same ratio, and an included angle. Nope, that's not going to be this case. That's going to be, yeah, it is. Yeah, sorry. I see what's happened. All right. Annabelle, since you've been pretty comfortable with this, let's see if you're going to get this one right. AB is matching to which side?
AB is matching to.
I like that you're delaying,
Um,
which means you realize something. But anyways, AB.
I don't think they're congruent. I don't think they're similar.
You don't think they're similar?
No.
Yep.
Because
let's see. So AB to
AB 39
to XY.
Oh,
That needs to be the same as.
it needs to be the same as BC to YZ.
So let's check. That's it. That's the best way to do it, right?
Yeah.
24 on 39. Is that the same as 52 on 18? I mean, just by looking at it, you can see the numerator is smaller here, whereas here the numerator is bigger. So definitely won't work that way. Just check one other one. Yep, but I can make it. You're not right. They are similar. So anyone identify how they can be similar? So this one's wrong. She tried it, didn't work. It's okay. I'll give you a clue. When I say this word, does anything come to mind? Transformations. Any words that you associate with this word? Transformations.
Transform.
There was 3 things that you would have done back in all the way, like in year 7. Transformations. I'll give you one of the words. One of the words was it wasn't that. It was translate, which meant you move it left and right, up and down.
Oh, and then wasn't it like flip or rotate?
Rotate.
Oh.
Good. And there was flip, but we didn't. It's not called flip. It starts with R as well.
Reverse. Reflect.
Yeah, reflect. So what you guys got to see, sometimes some triangles might look like this, right? And as Annabelle tried, she tried this and realized, yeah, it doesn't really work. Like AB to XY is not the same as BC to YZ. So she just automatically went, okay, since it doesn't work, it's not similar. but I can see some of this stuff happening. It's obviously not a translation. It looks like it is a, I mean, I wouldn't say it's a rotation. I would say it's more of a reflection. But let me show you what's happened as best as I can. All right? Let me show you what's happened. Whoops. Let's get these two. And let's go here. And then, and let's get this guy. And then again, paste. All right. Let's see. If I rotate this and try to make it look like the XYZ, I guess there it is. No, it's not a rotation. That's why. Not a rotation. And it's not a rotation, it's a flip. But how do I show you guys that flip? If I go like this.
Sam, I think you should redraw it.
Yeah, but if I redraw it, the problem is it's just going to am I going to, it's hard not being able to do this face to face. Look, so the way this how do I show you guys this? I can give you the answer straight away. It's not the answer I'm worried about. It's just what I want you guys to see. All right, let's see. So we've got a triangle that can look like this. Let's call it A, B, C. If I take a mirror image of this, can you see that it can actually still look exactly the same? B will still be up there, but what will happen with C and A? If I take a mirror image from the front, well, they could possibly move around. Do you guys agree with that? Does that make sense?
Yeah.
So technically what's happened, if you want to see it, I mean, I've rotated this way. So think of a triangle and, all right, how about this? So picture this triangle and you can see right now, if I'm looking at it from the front, so exactly as you're seeing it from the screen, the C is on your right-hand side, right? And the A is on your left-hand side right now. Now think about, now you got to, it's tricky, but you got to try to do this. Think about the person that's going to stand behind this and is facing you. So they're standing behind but facing you. How would they see the C? Can you see if they're facing you, that C would be on their left side, and then the A would be on their right-hand side? Does that make sense?
Sam, isn't it like when two people are facing each other, like they're facing opposite directions, one person's left and right is going to be different to another person's left and right?
Yeah, that's exactly what I'm trying to get to. So you get that? So you can see why this can work. So if I've got a triangle that looks like this, if I rotate it about this direction, if I'm going to rotate it 360 degrees, it will eventually look like this. So to you guys, AB could be 1, this could be 2, this could be 3. I can still give you these angles, you know, I can still say that's 20 degrees, and look, that's 20 degrees, and that is still 3, but what you didn't realize is that's a 2 and that can be a 1 now. but that 20 degrees is still in the same spot. So to your eyes, you're looking at it as, oh yeah, 20 degrees is in the same spot, and therefore these numbers should be the same. But in reality, what you haven't seen that's happened is it's been rotated, 360 degrees. It's pretty much been reversed. So what's happened to this triangle is if you reverse it as well, exactly the same thing, it'll look something like this. There's your x. Your x doesn't change. But what actually is going to go up here now? If you flip it, so you've got to flip this like this. What would move up here? What letter would this be? Can you guys see that's going to be Z and then that's going to be a Y? Can you guys see that or not really? Yes, no, I don't know. You guys gotta let me know. Maybe not. Maybe take your time. Take your time. You're flipping it. I don't know how else to show you this flip. Oh, hold on. Okay, let's do it again. So I've got this. I've got A, B, C. I've got 1, 2, 3. Let's draw a dotted line here. And let's flip. What's going to happen when you flip it to this side? Right? When you exactly draw this, when you fold your paper, you're going to get the exact same shape. There it is. There's A, but by the time you open this up, can you see that that 2 will be there? That's going to be a 2. And then that 1, because it's further away from your paper, it's further away from the middle. So then again, 1 will be here, further away from the middle. And then B is closer to the middle. So this is going to be B. This is going to be C. If you guys literally have paper next to you, draw a quick triangle in maybe Texta, if you've got Texta, and then fold it exactly like I'm showing you in half. You'll see you'll get exactly this triangle. Is that a little bit better?
Yeah.
I'm trying my best. Can you really see that? Is that making sense? So to you, again, this might look like the same triangle, which it does. So therefore you might think, because the A's are the same, you might think, oh, Sam, but then, this side is the same as this side. But in reality, it's not, because it's actually flipped. And what you haven't realized is this side's the same as this side. And that's what's happened up here. So we're going to look at it, flip it. If you flip it, so maybe I'll paste it down here. So let me see if I can do this. So now let's get this exact image. Let's see if we can make this guy exactly like this. Edit, paste. And I'm going to draw, a dotted line here, and we're about to flip this about this line. So when I do that, can we all agree that it will look exactly the same? X will still be here, but when you flip it, see how Y is closer to your line? Y is this length, so that should be Y. That guy has to be Y. And then again, since that's Z, further from this line, that guy's going to be Z. And if you see something like this, you can still see that's 40 degrees. That's 18, right? That's 40, that's 18. But then all of a sudden, XZ becomes the unknown, and XY is my 39 meters. Can you guys see that? Yes, no, maybe, I'm confusing.
Kind of.
Yeah, it's a hard exercise. I got to think about how to show this flipping next week. It's okay. This is what I was trying to get to. I was trying to get to, if you do now 18 on, what was I trying to do? 18 on 24 on 18, that should be the same as 52 on 39. That's what should happen. Yeah. So if you see this, I know it's hard to see. 24 on 18 should have been the same as 52 on 39. If you check that out, 24 on 18 is 1.33. 52 on 39 is also 1.33. But it's okay. I'll have to think about how I can actually show you guys a reflection like that next week. It's a tricky one to do without physically showing you. What I would usually do if we were face to face, I would actually just get this thing and literally rotate it 360 degrees in air, and then you'll be able to see the figure a little bit better. But I gotta probably get you a video out to show you how this works in air. That's okay. Let's leave it. It's okay. Before I start confusing more of us, let's leave that. All right. That's the question to finish it off on a good note, hopefully. Question 2. In each diagram, state the test that would be used to prove the triangles are similar and write the similarity statement. Okay. Zara, I guess you can finish us off with this last one. What do you see?
Is it reflected?
True. Hold on. Forget the transformations. Don't worry. I was just trying to get to, that was just specific for this concept. Forget the transformations. What do you see? You see parallel lines. So to prove similarity, the biggest one that you're going to use 99% of the time is angle, angle, angle. The 1% of the time is going to be ratios. So 99% of questions, 1% of questions. So it's usually about angles rather than sides. So what angles are the same?
Angle CAB
CAB equals
and CDE.
angle CDE. Why? What's your reason?
Alternate angles.
Yep. And then angle, you just need one more. What's another one? Zara?
Angle
Yep.
AB and angle CED.
Angle ACED. Yep. Angle ABC equals angle CED. Alternate angles as well. And therefore, triangle ABC is similar to triangle DEC. And what's your reason? The reasons are there's only angle, 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 and then side, angle, side. For now.
Angle, angle, angle.
Yeah. A. All right, hold on. Let's see.